Hi, this is the third video of the series The Secret Lives of Data. If you haven't seen previous two videos about this, please go and watch. This is the continuation in that. So we are talking about the Raft algorithm, which is a popular consensus algorithm for distributed systems. In this video, I'm gonna talk about the log replication. I'm sorry about that. So we are gonna talk about log replication in this. I'm continuing with the Raft algorithm. Once we have a leader elected, we need to replicate all the changes to our systems to all the nodes. This is done by using the same append entry messages that was used for the heartbeats that I talked about in the previous video. Let's walk through the process. First, a client sends a change to the leader. The leader append the change to its log, and then it just sent to the followers the same log on the next heartbeat. So as you can see, it sent the logs and with the heartbeat, and the entry is committed once a majority of followers acknowledge it, and the response is finally sent back to the client. Now let's send a command to increment the value of 2. Just see the example very carefully. The client sends it sends with a heartbeat and sends back. Yes, it is committed. Our system value is now updated to 7. Raft can even stay consistent in the face of network partitions. Let's look at an example. Let's add a partition to separate A and B from C, D, and E. And here we have added a partition, right? Now only B and A can communicate, and the time is running out for D, C, and E. So as specified in previous videos, the election for the leader has been done for both the partitions. Because our partition, we now have two leaders in different terms. Let's add another client and try to update both the leaders. One client will try to set the value B to of the node B to 3, and node B cannot replicate to majority, so its log entry stays uncommitted. The other client will try to set the value of node C to 8 because it's the leader, it will communicate through it, and this will succeed because it can replicate to the majority. Now let's heal the network partition. So both of the our log is now consistent across our clusters because the re-election for the leader is done. So how does this leader election happen? Because the node C, which was the initial leader, will send the election term to the node B, and its value was less than C. At that moment it was 1, so it just gave up its leader position and became a follower for C. Our log is now consistent across our clusters. So towards the end, I'm going to conclude